All right, let's look at this example 8.6. So this 8.6 is also on your textbook in the 10th edition, as I mentioned. So you can also find it online on the PDFs. So this question, initial energy storage in the circuits is 0. All right. So both the capacitor and the inductor do not have any initial current or voltage. So that means no energy storage. This is the best to see assumption you can have. Okay, it's easier than most of the other questions. At T0, so initially the DC current source is 24 milliamp is applied to the circuits. So the value of the resistor is 400. Okay, so what is the initial current of IL? Okay, so initial current IL0 equal to 0 because there's no energy. For part B, what is DI dt? So DIL dt. So the change of so we have this equation, DIL dt multiplied with L equals to VL. Okay, so that's the thing. That's the equation for the inductor. So DIL dt actually just equal to VL over L. Okay, and the is also equal to VC over L. Okay, because we know the capacitor doesn't have any energy initially, so VC is 0, so everything is 0. Okay, so that's the part B. And part C, what is the roots for characteristic equation? So it's going to depend on what cases. Then we need to do the routine, right? We have to find out the alpha is 1 over 2 RC. Everything is given, okay? R is 400 and C is, how much is C? Is 25 nano. All right, so the alpha, if you do the math, equals to 5 times 10 to the order of 4. And for omega 0, we can do square, so we can avoid this LC thing, the square root things. And this one equals to 16 multiplied with 10 to the order of 8. And we can compare omega square with alpha square. We will find alpha square is larger. So this is over damped. Okay. For this over-damped one, then the root of characteristic equation is negative alpha plus minus alpha square minus omega square root. Then we have all the numbers, right? We plug it in. Then we have this. We have S1 equals to negative 20,000 and S2 equals to negative 80,000. All right. And part D, what is the expression for IL? Okay, so the expression for ILT is this one. So IL infinite, so steady state value, plus, because this is a forced one, right? Plus A1 e to the order of S1t, we know S1 already, and plus A2 e S2t. Okay, we talked about, so let's look at the final value for the inductor current. Okay, so the inductor current in the end, steady state, inductor current going to become short circuit 1t equals to infinite, right? So all the current will go through that. That's pretty easy. Then this one is 24 milliamp. Then we need to find out A1 and A2. We do this through initial condition. So in the class, we derived how to do that. So if that's the IT expression, right? If we set all the t equal to 0, that's the initial condition, okay? And then T0 initial condition equals to, we just do that, and then you plug it in, then it's actually A1 plus A2, okay? And that equals to how much? That's equals to 0. IL is 0 initially, okay? So that equal to 0. Then if we plug numbers in here, let me do that. So how much is this? Is 24 milliamp plus A1 plus A2 equal to 0. Another one is you do a derivative. Okay, you do a derivative of t, and you plug t equal to 0. Then you got di 0 dt. We know that is actually equals to vc over L, because vc is 0, or vc equal to vl, right? It's parallel, so equal to 0. So the whole thing equal to 0. And you do derivative of every one. Of course, this one is gone, and this one is still there. So you got an A1 S1, because that one is, you got an ES1T here, right? If you plug T equal to 0, then this gone. This equal to 1. That's why it's not here. I derived this for you because in the exam equation sheet, it doesn't give you this clear one. They give you a longer equation. You have to do derivative yourself. Okay, and A2 S2. So that's the equation. And then we have this two equation, equation number 1, equation number 2, and then we put them together. Then we can solve that. A1 equals to negative 32 milliamp, and A2 equals to 8 milliamp, and then you can just plug it in into this one. Okay, so the final result, ILT equals to 24 minus 32. I put a milliamp in the end, so negative 20,000 T plus 8 e to the order of negative 80,000 T. Then we have milliamp here. Okay, all good.